We're going to talk about the unit circle today, but just a little bit about circles in general. When you're graphing a circle centered at the origin can be represented by the equation x squared plus y squared equals r squared, where r is the radius of the circle. And then it just asks you to draw each circle. The first one is x squared plus y squared equals 4. Its center is at the origin. What's the radius of this circle? So remember, x squared plus y squared equals r squared. R squared is equal to 4, so r is equal to 2. Right? Take the square root of that number. So if you were to draw it, this is not going to be easy for me to draw on here. But you have to go up 2 and over 2. And you'll end up with a circle that's around there. It's not very round, but you get the idea. The radius is 2, and the radius, it means that every point is 2 units from the origin. So if you were to look at the distance from the center and then straight out to the right, that would be 2. Straight up would be 2, but if you went diagonally, that would also be 2. In any direction, it's 2. That's kind of the definition of a circle, right? It's this set of points that are all the same distance from one point, which is the center. So the next one, x squared plus y squared equals 49. What's the radius of that one? 7, right. So from the center, go out 7 in every direction. But I'm just going to go here, here, those 4 spots, and then kind of join them in something that looks somewhat circular. Not perfect. It's not easy to draw on here, but you get the idea. A circle centered at the origin with a radius of 1 has the equation x squared plus y squared equals 1. This special circle is called the unit circle. It's called a unit circle because its radius is 1 unit. So it's a unit circle. Draw the unit circle and determine if each point exists on the circumference of the unit circle. So it gives us this point, 0.6 and 0.8, and we need to decide, is that or is it not a point that's on the circle? So I'm going to draw it, and if you see the scale here on this graph, each of these is 0.1. So the ones and the negative ones are right out at the edges. So the circle goes all the way out to there. Once I draw the circle, you can kind of estimate whether or not you think those points are on the circle, but it's not drawn very well. Maybe if I used a compass and drew it, set the radius to 1 and drew it, but I can't do that here on the iPad. So you could estimate 0.6 and 0.8 would be, where would it be? 2, 3, 4, 5, 6. It's like right around there. Does it look like it's on the circumference of the circle? Yeah, but like I said, it's not drawn very well, so we're going to have to figure out another way to determine whether it actually is. The other one was 0.5 and 0.5, which is around there, which does not look like it's on the circumference, but let's see. We need to use the equation x squared plus y squared equals 1. And what can I do with that equation? Replace the x and y with the x and y value that we're given. So I'm going to do 0.6 squared plus 0.8 squared equals 1. And then when I simplify the left side, 0.6 squared plus 0.8 squared, what does it have to equal if that's actually on this circumference? It has to equal 1. So 0.6 squared plus 0.8 squared actually does equal 1. It's 0.36 plus 0.64. We get 1 equals 1, which means that that point at 0.6 and 0.8 actually is on the circumference of the circle. Then if we try 0.5 and 0.5, same thing. I think we already know the answer, but 0.5 squared plus 0.5 squared. Which is just 0.5 equals 1, which means this one is, but this one is not, which is what it looked like anyway when we plotted the points. When we're talking about this 0.6 and 0.8 being on the circumference of a circle that has a radius of 1, we can kind of think in terms of, well, the right angle trig that you already know. If I take that point, it's right there, and I make a triangle that goes from the origin. The 0.6 is here, the 0.8 is here, the 1 is here, it's the radius, right? So from the center directly to the point, it's also the hypotenuse of this circle. And if you think about a hypotenuse and how you find it, c squared equals a squared plus b squared. Well, c here is the radius. A is the x value, so x squared, and b is the y value. X squared plus y squared equals r squared. That's the Pythagorean theorem at the top. At the bottom, that's the equation of a circle. And that's why it's the equation of a circle. It just comes from the Pythagorean theorem. But it's kind of a neat connection for you to see. And it's an important connection for you to see for what we're going to do next. So this one says, using the equation of the unit circle, x squared plus y squared equals 1, find the unknown coordinate of each point. And then, is there more than one unique answer? So, x squared plus y squared equals 1. Is that, or what is the y coordinate when the x coordinate is 1/2? That's what it's asking you. So we'll do 1/2 squared plus y squared equals 1. Y squared equals 1 minus 1/2 squared. What is 1/2 squared? One quarter? Right? You can just square the numerator, square the denominator. So 1 squared is 1, 2 squared is 4, so it's 1/4. So y squared is actually equal to 1 minus 1/4. 1 minus 1/4 is 3/4. And then take the square root. But we need a plus minus there, right? Because we're square rooting that variable, y. So the y coordinate is equal to positive or negative. I'm going to change this to √3/2. Because if you remember back to radicals in grade 11, you can't have a square root on the bottom. We have to simplify that. This one's easy to simplify because it's a perfect square. Makes it easier. But there's the y value. So is there more than one unique answer? Yes. There's √3/2 and negative √3/2. And we're just going to leave it like that. You could get a decimal answer, right? But when we're working with the unit circle, we're going to leave our answers in that form, in radical form. So for the other one, same thing, except it gives you the y value. So we're going to do x squared plus √3/2 squared equals 1. 1 minus √3/2 squared. √3/2 squared is 3/4. Right, square root 3, that's 3, because the square root and the squared cancel each other out, and then square the 2, it's 4. So 1 minus 3/4 is just 1/4. and then take the square root, positive and negative square root, x equals positive or negative. Square root of 1/4 is 1/2. So those are some of the types of questions that you might be asked to do. Yes. We need to consider the fact that it says that the point is in quadrant 2, which means we should only have the negative 1/2 as the x value. Only one answer. Because positive 1/2 is in the first quadrant. Exact values for special angles. These are the two special triangles. And I'm just going to write them over here a little bit bigger because it's hard to see. So they're given, the angles are given there in degrees, but I'm going to just put them down in radians. This one is pi over 3. This one is pi over 6. And then that's pi over 4, and in there as well, pi over 4. You need to memorize them exactly as they are. So the angles and the side lengths, and make sure that they're placed appropriately. So if you look at the first one, like the 1 has to be opposite the pi over 6. The 2 has to be opposite the right angle, and so on. If you can remember the numbers, though, you can probably figure out where to place them, because the smallest angle here at the top has to be across from the smallest side. And the hypotenuse has to be the biggest number. Like, you could probably kind of remember that. But we're going to use these a lot, and you will, I'm sure, have them memorized. The other thing is what sometimes we call the cast rule here at the bottom. And it's called the cast rule because it spells the word cast. There are different acronyms for it.
All students take calculus.
Yeah, some people say all students take calculus or ACTS, A-C-T-S. C-A-S-T is the way that I remember it. It doesn't really matter how you remember it, as long as you remember that which quadrant has which letter in it. So I always start down here and go C-A-S-T and call it the cast rule. But if you have another way of doing it, that's fine. So what it means, when you look at the C, it means that in this quadrant, the cosine of any angle in that quadrant is positive. If the cosine is positive, then all of the rest are negative. Except the reciprocal of cosine, which is, do you know that? Cosecant. Not cosecant.
No, cosine. The one of sine.
Yeah. So what's the one for cosine? Secant. But we'll talk more about that later. So cosine is positive there. When you look at A stands for all. All of the ratios are positive in that first quadrant. S means sine is positive, which means cosine and tangent are negative there. Sine is the only one that's positive, well, that and its reciprocal. And then for T, tangent is positive. What we're going to do with that is use it to fill in this unit circle.
Did we fill this in already?
We did not fill this in already. We filled one in that had only angles. This one has angles and the coordinates of points. This should be what you have in front of you. And I'm just going to show you how we're going to fill it in. Well, it shows you here on the right, P of 0. That means the angle. It means the point at angle 0, P of 0. And what would the coordinates of that point be? So we're talking about, this point right here that's in red. Can you see that? What are the coordinates of that point? 1 and 0. Right. So we're going to put in there 1, 0. And we can also do it for this. This point has 2 labels. P of 0, angle 0. What's the other angle that we measure there? 2 pi. is if we went all the way around the circle. So this would be P of 2 pi is also equal to 1 and 0. Then if we pick, I'm just going to do the next point. This point here so that point is at an angle of pi over 6. We did these angles the other day, right? So that angle is pi over 6, but we needed to figure out what are the coordinates of that point. So this is a little bit more difficult than just looking at the point and saying it's at 1, 0. The ones that are on the x and y axis will be easy, the rest of them not so easy. But what we can do to figure it out is consider the special triangle that has pi over 6 in it, which looks like this. One, 2 root 3, pi over 3 and pi over 6. And we're going to need to figure out the x and y coordinates of that point. So I can draw this triangle actually here, where this angle in here is pi over 6, which means, well, we know that this is not actually equal to 2, right? That hypotenuse, but it's the same ratios as that triangle has. So any triangle that has those angles is going to have the same ratios as the special triangle. So we can think of it as being 1, 2, and root 3, even though those aren't the actual measurements. Those are just the way that the side lengths are related. So what that means is that this hypotenuse is twice as big as this side, because it's 1 to 2. And then the way that these are related, 1 to root 3. So they're not actual measurements, but well, they could be, but they're not for the unit circle, right? Because we know the hypotenuse is 1. But we can use that to find those side lengths. And we're going to do it based on the fact that on the unit circle, the points x, y are actually the cosine of the angle and the sine of the angle. So the x coordinate of a point on the unit circle is the cosine of the angle. The y coordinate is the sine of the angle. So to find the cosine of pi over 6, how do we find cosine? Adjacent over hypotenuse. So look at where the pi over 6 is. Here. The adjacent side is root 3. The hypotenuse is 2. That means that the point is at root 3 over 2. And then the sine of that angle, so we're still looking at pi over 6. The sine is opposite over hypotenuse, so it's 1 over 2. Root 3 over 2 and 1 over 2 are the coordinates of that point. Let's have a quick look at this one over here. What's the angle here? You may not have done that yet, but what's the angle here? 5 pi over 6. So here's the problem. I don't see a 5 pi over 6 anywhere on my special triangles.
So do you use the angle from the x-axis?
Yeah, and what do we call that?
Reference angle?
The reference angle, right. You have to use the reference angle for these ones. Your triangle is actually here. You draw it to the x-axis and you use the reference angle. So what's the reference angle? Pi over 6, which means we can use this triangle that I already have drawn up here that has a pi over 6, and to find the cosine, it's adjacent over hypotenuse, so root 3 over 2. And the sine is opposite over hypotenuse, so 1 over 2. But if this is root 3 over 2 and 1/2, then this can't be root 3 over 2 and 1/2. Negative root 3 over 2 and 1/2. So we have to add the negative in there. A couple of ways that you can figure out what's positive and what's negative. Just look at the point. It's obviously a negative x value and a positive y value. If you consider that cast rule, CAS, this is the S quadrant, sine is positive, cosine is negative. So you can think of it that way as well. But if you just look at where the point is, you should be able to figure out what's positive and what's negative. Here's the answers. If you're still trying to figure them out for yourself, you don't have to look at them yet. But you will notice that there are patterns. Basically, if it has the same reference angle, it has the same coordinates, just the signs are different. When I was in high school, my pre-calculus teacher told me to memorize the unit circle.
Did you?
I shouldn't record this, but I'm going to. No, I didn't memorize it. That's ridiculous. I don't have room in my brain for all of that to be memorized. I can easily figure out anything that I need on the unit circle, so I'm not going to bother to memorize it. Some of you, if you're really good at memorizing, maybe you do want to memorize it, and there are definitely teachers that would tell you to memorize it. But for me, if I want to know the coordinates of that point at 3 pi over 4, I have the special triangles memorized. I don't need to memorize those points. I can find them out really quickly. So I guess it's up to you. If you want to memorize it, you can. If that's kind of what your strength is, that's definitely not my strength. It took me 2 months to remember all your names. No, that's not true, because I already knew most of you, so it didn't take me very long. But I only had to learn about 5 names in here. But I'm not good at memorizing. And so I would not memorize this. I still don't have this memorized. If I need to know one of the points, I'll calculate it really quickly using the other stuff that I do know. But there it is. When you're ready, you can check your answers.